Structure initialization. Like a variable of any other data type, structure variable can also be initialized at compile time. Now let us see how we can initialize a structure variable at compile time. Struct patient, within the curly brace I am writing the member elements, that is float height, int weight, int age, and I am closing the structure with a semicolon. Next time we need to write struct patient p1 equal to whatever the elements we have, we need to write it as according to the order. That is, first one is height. So I am taking the height 180.75, comma weight I am taking it as 73, comma age as 23. So this is what an initialization. We can initialize in the other way, or struct patient p1. So p1 is an identifier of patient structure type. So p1 dot height equal to 180.75. So we can initialize the each member separately. So here we are going to initialize with the dot operator. P1 dot height equal to 180.75. P1 dot weight equal to 73. P1 dot age, which is equal to 23. So this is how we can initialize the structure elements.
Let us see one example program.
The next program is to declare and initialize structure variables at runtime. Now, how to read the structure elements at runtime? So here I am removing this initialization struct. This is a static initialization where you run this program n number of times, you are going to get the same output, but I want to take at runtime. So here struct student of S1. After this I require the printf message specifying to the user enter name of student, enter name of the student. So here I am going to read name of the student using scanf percentile yes, name is percentile yes, followed by name. So this is how we are going to read the name of the student. Next, simple name we are going to read in this way, but as it is a structure variable, we need to use s1 dot name. This is very simple. How you used to read the name in the earlier programs, by directly giving the name identifier, but this name identifier is part of this particular student structure. That is the reason why we need to access with the help of s1 dot name. Similarly, I can write a multiple printf as well as multiple scanf statements where I can read the rest of these three all together. So I can write like printf enter marks, percentage and fees of a student. So here also we need to specify the same order when we are reading the data. Scanf. So what is the first one we are going to read here? Marks, percentile D, followed by the next one is percentile F, that is where we want to read percentage, and the next one is percentile LF to read fees. Here how we need to write the address of s1 dot marks, comma next address of s1 dot percentage, comma address of s1 dot fees. So this is how we are going to access the student details we are going to read with the help of scanf statement. Now after reading this, if you want to print them, so this is how we are going to print them. So the printing is same, right? But we have read this at runtime. Now let me execute this code and show you how we can read the data at runtime using structures. So here enter name of student. So name of the student is Manijit. Now enter marks, percentage and fees of the student. Now here we need to enter according to the scanf whatever the order we have specified. So first one is marks. So I am giving marks as, let's say 90. 90 is the mark. Next enter. We need to enter according to the order I have said. Here the next one is, value what we need to enter is percentage. So I am entering the percentage as some 85. Next immediately we need to enter the fees, s1 dot fees. Now I am entering the fees 45,000. Enter. So name equal to Manijit, marks equal to 90, percentage equal to 85.00, C is equal to 45,000.6 zeros after this point. So this is how you can run the program a number of times, and you can see the different you can give the different input, and according to the input you can get the output. So this is how we can implement the structures, and we can declare and initialize the values at runtime. You run the program for n number of times with a different input, we will be getting the different output. So let me execute once again with a different input. So I want to give the name of the student. Name of the student is Manvita. Manvita is the name of the student. So enter the marks. So I am giving marks as 100. So percentage is 98, and what is the fees is, let's take 35,000. So name equal to Manvita, marks equal to 100, percentage is 98.00, fees is this one 35,000.000, right? So this is how we can give the input and get the output at runtime. The next problem statement is to understand the memory allocated to the structure. So as we know that a structure memory will be the addition of all the individual memberless size. Now let me first give the size of the individual structure elements, then followed by the entire structure. So I'll be giving printf the size of name is, so if I want to give the size of the name, so we have size of is a keyword, followed by I need to give s1 dot name. Similarly, I can give the different sizes of all the identifiers, that is the member list elements which I have specified in the given structure name. So the next one is the size of marks. The size of marks identifier is s1 dot marks. Next, the size of percentage. The size of identifier name percentage is. So everything is size. It is an integer value. So even though the data types are different, here I am using percentile d because the size is of integer type, right? So the next one is size s1 dot percentage. Next, the size of fees identifier. So size of fees identifier is percentile d, here s1 dot fees. Next, now let me give the size of this s1. As I said, struct student s1 is like similar to int from a. Now here, as this is an user defined data type, here in the place of int we are just writing struct student. In the place of int we are writing struct student, followed by here in the place of a you are writing the structure identifier name s1. That's it. So this is like similar initialization how we used to do for the primary data types. Now this is our user defined data type struct student. We are defining a student with a data type name, okay, followed by, and the contents will be stored in this s1 identifier. Now let us see the size of s1. So I hope you understood it clearly. Here when I say name, size of name, the data type is char. Size of marks, then the data type is integer. Size of percentage, the data type is float. Size of fees, the data type is double. Similarly, if I want to take size of s1, the data type is student, which is of structure type. Now here I'll be writing only s1. Now let us execute this code and see the individual sizes associated with the data type. Now if you can see this output closely, the size of name is 20. Here we have initialized with 20 into 1. As we all know that character takes 1 byte, 20 into 1 is 20 bytes. The size of marks is 4 bytes. Because integer takes 4 bytes of memory for storage. Next, the size of percentage. The percentage is float type. So float also takes 4 bytes. Next, the size of fees. So fees is a data type which is allocated with double. So double takes 8 bytes of storage. Now, as a definition of memory allocation for the structure, so structure takes all the individual variables sum of their sizes. Now, if you see this output, the size of name is 20, the size of marks is 4, the size of name is 20, you got that as it is a character type, so 20 bytes. The size of marks is 4 bytes because it is an integer. The size of percentage is 4 bytes because it is float. The size of fees is 8 bytes because it is double. Now, if you can see, the size of structure variable S1 is 40. So this is the actual sum of individual member list elements. Now, if you can take the sum 20 plus 4, 24, 24 plus 4, 28, 28 plus 8, 36. So totally 36 bits are allocated from the structure variable, and extra 4 bytes are being used for the alignments of your data. So this has been allocated by the compiler. Actually, whenever you take the internal compiler, it takes the multiples of 4. Now, if I am taking the size here as, for example, 16, so let me take 16, then your size will be the accurate size, that is 32 bytes. So 16 plus 4, 20, 20 plus 4, 24, 24 plus 8, 32. So this is how you're going to get the exact size, right? Now, let me take one extra bit over here. If I am taking 17, then if you can see this output, you will be getting 40 bytes because it will be taking the multiples of 4, because it will be taking the multiples of 4. 17, 4, 4, 8, then it will take this 40 bytes. Okay. So this is how the memory allocated for the structure variables can be seen in detail.